All right, Algebra 2 guys. This is section 3.3 talking about solving systems of inequalities by graphing. So take a look at one situation here. During one heartbeat, blood pressure reaches a maximum pressure and a minimum pressure, which are measured in millimeters of mercury. So it is expressed as a maximum over the minimum. So for example, 120 over 80, which is a pretty healthy blood pressure. Normal blood pressure for people under 40 goes from 100 to 140 for the maximum and 60 to 90 for the minimum. So express this as a system, as a set of inequalities. So this is kind of the area that you want to be in. All right, so you would like x to be greater than or equal to 100, but we would also like x to be less than or equal to 120. You would like y to be less than or equal to 90, but you would also like that to be bigger than 60. So if I wrote that as two compound inequalities, I would say this. X should be less than or equal to 120, 100 should be less than or equal to x. So this is your maximum, this is your minimum. This is kind of where you want to sit. So how does that transfer over to what we're talking about? Well, take a look at this. Classy catering needs at least 15 food servers for a party and 5 bussers to cater it. So in order to make a profit, they can have no more than 34 food servers and 7 buses working an event. Let's write a system of inequalities to represent that. So you need at least 15 food servers and 5 buses. You can't have more than 7 food servers and 7 bussers. All right, so if we let food servers be the x and the bussers be the y. So the food servers, you've got to have at least 15. All right, so that's going to be x greater than or equal to 15. But you've got to have less than 34. So x less than or equal to 34. For the bussers, you got to have more than 5, but you cannot have more than 7. So your compound inequalities your inequalities kind of look like this. So for food servers, you're going to need x less than or equal to 34, but bigger than 15. Then you're going to need y is less than 7, but bigger than 5. So that is about all you can have for that. So let's take a look, do a little quick review of solving a system of inequalities by graphing. So if I take a look here, y less than or equal to negative 2x plus 4. If I take this first line, this will be in black. So that's down 2 over 1, down 2 over 1, down 2 over 1. There's my mark. So now I've got to look and see, do I have, which way do I need to shade? So if I put in 0 less than or equal to 0 plus 4, well, is 0 greater than or equal to 4? No, that's false. So I'm going to shade away. The second one, this one I'll do in blue. Y equals x minus 2. So here I'm starting at negative 2, but my slope is just x. It's a solid line. So now I need to check 0, 0 again. So is 0 less than or equal to 0 minus 2? Well, is 0 less than negative 2? No. So 0, 0 is false. So I want to shade away. So now I got to look for, where does it overlap? Well, it overlaps right in here. So that is my area. So now, quick recap. I graph it like it would be a line. Solid because these two have got equals underneath of them, okay? It's not just less than and greater than. It's less than or equal to and greater than or equal to. Then to figure out which way I shade, test 0, 0. Put 0 in for x, 0 in for y, see if that's a true statement. So take a look here. Absolute value of y is less than 3. Okay, so pretend that that's kind of an equal. So y less than 3 is going to be right here. Y less than 3 is going to be right here. Dotted line. So am I going to go up or down? I'm going to go down, but here's kind of the other limit. Um, I'm going to go down, but there's a second part to this. So that means, remember what absolute value means. That means either y is less than 3 or sorry, not or, and y is greater than negative 3. So that means I've got it down here as well. Shade up, shade up, shade up, shade up. So now the second one I'll do in red, y greater than or equal to x minus 1. That's going to look like this. Solid line. There you go. So now if I put in 0, 0, is 0 greater than or equal to negative 1? Yes, that checks. So I shade towards 0, 0. So my solution area is going to be right there. That's going to be my solution area. All right, so slope-intercept form is very, very nice when you can get it because it tells you almost exactly what you need to do. So this top one will be in blue. So I start off at 4. 1/4 means I go up 1 over 4. I can kind of mirror that going back. Dotted line. Test 0, 0. Is 0 less than 0 plus 4? Yes. I shade towards 0, 0. And I mark that with arrows because I'm not done yet. So this one will be whatever color that is. So negative 2, up 1 over 4, back 1 over 4, up here, solid line. Then I got to test 0, 0. Is 0 greater than or equal to negative 2? Yes. So I shade this way. So this area in here is going to be my solution area. So what that means is that anything in there is going to satisfy both of those conditions. So take a look at this one. Now we are in standard form. So I can do one of two things. I can either go by intercepts or I can convert to slope-intercept form. It's really your choice. So if I go just go by intercepts, so I'll let y equal 0. X in this case will equal negative 1. So x is a negative 1 right there. So if x equals 0, negative y equals negative 1, so y will equal 1. So there's my equation. It's going to be a solid line right there. Then if I put in 0, 0, is 0 minus 0 greater than or equal to negative 1? Yes. So I'm going to shade that way. This one, 3x minus y greater than or equal to 4. This one I think I'm going to convert to slope-intercept just because it might be easier. Negative y is less than or equal to negative 3x plus 4. Now, if I multiply both sides by negative 1, first off, I need to change the direction of the sign, and this becomes positive 3x minus 4. So, minus 4 right there. Solid line again. Does 0, 0 work? Well, is 0 3 times 0 minus 0 less than or equal to 4? Yes. So that means I'm going to be right in here. That is going to be my solution set. So take a look at this one. You've got three kind of situations here. Y equals 3 minus, y less than 3 minus x, which is the equivalent of saying negative x plus 3. So this is going to be 3, dotted line, right there. So 0, 0 works. Okay, if I put in 0, 0 less than 3, that's a true statement. So then y greater than or equal to 3 is going to be above it. And then x greater than -5, that'll be in green. At -5, oh, that should be a dotted line. That should be a dotted line. And then bigger than -5 is all going to go this way. So after all that, my only shaded area is going to be right up here. That's going to be it. Okay, get going on your assignment. Come talk to me the questions. Get this figured out because it only gets more complicated from here. All right, have a good one, and we'll talk to you soon.